I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we'll understand how do we find area of a regular triangle, which is equilateral triangle, using Apothem. This concept will be utilized in finding area of regular polygons also in this particular video. The question here is, find area of the following regular polygons, round your answer to 100th if required. So we are given three different conditions here. These are all equilateral triangles, let me mention that. So regular means all sides are equal, all angles are equal, correct? So that's what we mean by regular, right? So all sides are equal, all angles are equal. The formula given is area is half apothem into perimeter. Now perimeter is sum of all the three sides, as you know. So perimeter is sum of all sides. In this particular case, right? And apothem is the shortest distance from the center to any side, right? That is apothem. So let me define here apothem. It is the shortest distance from center to any side. So as shown here, so that is the apothem from center to any side, right? As you can see, in the first case, we are given the side length and the apothem. In the second case, we are only given the apothem, not the side length, and then we are given the side length and not the apothem. The idea is, if any one of them is given to us, we can always find the others. Simple relation of trigonometry. We know in this particular case, all angles are 60 degrees, correct? Since all angles are 60 degrees, it's an equilateral triangle, as you know. You can always connect the apothem with the vertex and then find A if the side is given to us using trigonometric ratios. So this length, which will be half of the side length, will be related to apothem, and the angle here in equilateral triangle, this angle will be 30 degrees. So you can use tan of 30 degrees as apothem A over half of the side length, right? And what is tan of 30 degrees? Tan of 30 degrees you can use from special triangles. So for an angle of 30 degrees, side length ratio will be 1 over square root 3 for tan, right? So you can use this particular triangle. So with all these concepts, I think you are in a position to answer this question. Perfect. So we'll take up the solutions one by one now. So the very first one is given to us. Side length S, each side is 14 square root 3. So that gives us the perimeter P, which is 3 times the side length. So I can write perimeter as 3 times 14 square root 3. Perfect. Now we are given the apothem A, which is 7. Units are meters, so area will be in meters square. The area formula is half apothem times perimeter. So let's calculate this now. So the area is equal to half apothem is 7 and side length is 14 square root 3. There are 3 such sides, so we'll multiply by 3. That gives us the complete perimeter. Clear? You can simplify this and then write down your answer. So we get 49 times 3. Let's write in brackets square root 3. As the area, the units will be meter square. Perfect. So let's write down the answer. Area is 3 times 9, 27, 2. 3 times 4, 12, 147, square root 3 meters squared. Is that clear to you? So we'll leave this as the exact answer. So that gives you the process of calculating the values using the formula. Now let's move on and take up the next example where we are given the apothem, right? So here we are given apothem A, which is 3 meters. We need to find the side length. So for that, let us connect with the vertex, the center O of this particular triangle. The angle here is going to be 30 degrees as it is half of 60 degrees. The side length, let's say if S is the total side length, in that case, half of S will be in this particular triangle which we are looking at. And the triangle is a right angle triangle. So we can relate them with trigonometric ratio, which is tan of 30 degrees. So tan of 30 degrees is equal to the apothem, which is 3 in this case, over S by 2. So we can now cross multiply and say S by 2. Half of the side length is equals to 3 divided by tan of 30 degrees. Make sense? You can use calculator to find tan of 30 degrees. However, it is a very special triangle, right? So not a problem. We can just sketch one. And you should remember these values. 1, 2, square root 3. Square root 3, and that is 30 degrees, correct? So this is 90, that is 60, correct? So tan of 30 is opposite over adjacent side. So we can say tan 30 is 1 over square root 3. Substituting this, we get this as 3 over 1 over square root 3, right? Which is 3 square root 3. So the side length S is 2 times 3 square root 3, correct? Which is 6 square root 3. So that is the total side length. And from here, multiplying it by 3, we get the perimeter, right? So from here, which gives the perimeter P, which is 3 times the side length. And let me write down that value, which will be equal to 18 square root 3. Clear? So we know perimeter, we know apothem, we can find the area, which is half times apothem times the perimeter, which is half times apothem is 3, right? Times 18 square root 3. You can now simplify this. Dividing by 2, 18 goes 9 times. 9 times 3 is 27. Square root 3 unit meter square becomes the area of this particular triangle. Absolutely clear, right? So we found the area when the apothem was given to us. Now here is the third example in which we are given the side length, right? So we know now in example 3 that side length is 10 meters. And that gives you the perimeter, which is 3 times the side length, or 3 times 10, and that is 30. Right. Now in this case, we need to find what is the apothem. So let's connect the center with one of these vertices. We know now that since the side length is 10, half of it is going to be what? 5, right? And the angle here is 30 degrees. So we know from this particular triangle that tan of 30 degrees is equal to A over 5. So 5 times tan 30 degrees is the value of A. So we can find the value of A as 5 times tan of 30. We'll again sketch our special triangle, right? Let me do it here itself now. So we are sketching it again and again so that you can get to that is 30 degrees, right? 1 over square root 3. So 5 times 1 over square root 3 becomes A. Perimeter we already know, and therefore we can now calculate the area. So area A of this particular triangle is half times apothem times the perimeter, which is half times 5 over square root 3 times the perimeter, which is 30 meters for us. Good. So we can multiply this and divide. So this goes 15 times 5, right? So we get what? 75 over square root 3. It is a good practice to rationalize, right? So we'll actually rationalize it, multiplying and dividing by 3 itself. So we can write 75 square root 3 over 3. So rationalization basically means multiply and divide by the radical square root 3 over 3. That's what we did, correct? So square root 3 by 3, when you multiply with, you get 3 in the denominator, square root 3 comes in the numerator. You can divide 75 by 3 now, so get 25, right? Square root 3 as your area, which is going to be in units of meter square. So I hope with this, the whole process is absolutely clear. So what we have seen that in a regular polygon, we took triangle this case, which means an equilateral triangle. We could calculate the area if either apothem is given to us or the side length is given to us, correct? Using apothem. And we use a special triangle. The value of tan 30 basically is what was required to calculate this, relate the side length with apothem, which is 1 over square root 3, or you can write this as square root 3 over 3 to do your calculations. So with that, we come to an end. I hope it makes sense. Feel free to write a comment, share your views. If you like and subscribe to my videos, that'd be great. You can always contact me on the email address to learn more. Thanks for your time and all the best.